business like this, no, like water or kining sa power, metering devices or measurements are essentials. Now let's go to the actually sa distribution company ko, dapat is like division na in charge for the meterings. Isa gina siya ka division kay laylay man aside sa laylay ng customer, you cater huge daghan kayo ng customers.
Sa barangay.
Now, in terms of the technicals, as engineers, we're familiar with voltage control devices. These are usually introduced solution kung may problems like under voltage, or may very huge voltage drop along the feeder. So what are those voltage control devices? Could be large banks of capacitors, but na consequence po gumagamit ng capacitors. Aside from supporting the voltage, it could also inject huge amount of reactive power that pwede siya maka-disrupt or maka-distort sa inyong lines, no? And specifically, kung imong issue is voltage, you could have a tap changing transformer or a voltage regulator. So I think you're familiar with voltage regulators from electronics point of view. Ito itong mga 3 legs na IC. Gagamit mo ano?
Yes, sir.
So, ang function ni voltage regulator is just to regulate the voltage. No, whatever the load on the load side, dili dapat siya mo mas malesser ang iyang effect. No, kung sa point of view sa electronics, na dapat ang atuang voltage or atuang power supply. For example, power supply should be regulated. Unsa yung tendency kung dili regulated atong power supply? Example, naka 12 volts, nag-connect ka og resistor 10 kilo ohm.
Buto nga.
Pag naka-live ang 10 kilo ohm, pag measure nimo pilay voltage mo around 9, yang i-bring down ang voltage. Mana ang nature sa to ang load spot. Kay depende man sa power rating sa imong power sa imong supply. Mo adjust gina sa voltage para supply kanya ang current. Kaya nang pwede inversely proportional mo gina sa voltage and current. Now sa voltage regulator, iyang purpose is to regulate the voltage. Iya gina siya ni solidify ang iyang voltahe na dili siya maapektuhan whatever na load, dako kayo na load requirement, yan i-steady ang iyang voltahe. Pero naging time na naging tayo mga voltage drop, it's the consequence ng input sa distribute sa power, naging tayo voltage drop. Pero with the voltage regulator, we could provide added flexibility sa tuwang system na dili siya mo beyond the limit, mo operate at beyond the limits. Now, voltage control at distribution level is more difficult because of the lack of generations and low level of observability. What do you mean by lack of generation is because of siguro since naka-radial more of the users ang nasa line. Pero kung nanatay mga solar PV ang kanabalay, mas mo elevate ang ang voltahe mas pero napo na siya issue kung masobrahan ko do kadaghan sa solar PV, agian mo og clouds dira, tagak tanan. Mawala ang power sa PV agi mo ang linya sa distribution system mo drop po no. So that's why na regulation coming from the Philippine Distribution Code, the hosting capacity for every substation or sa distribution line is cut off lang siya at 30% renewable energy line. Intermittent or solar and wind. Pero unlikely na kayo na mga kitawag wind, more like sa solar. So, na-limit na 30%. But kanang 30%, generalize lang na siya. So, if you want to have a detailed limitations sa tuwang feeder, you can do that in your siguro thesis study. We call that term as hosting capacity. Pilay makaya sa tuwang distribution line na maka-host o solar PV. So then, according to the Philippine Distribution Code, ang voltahe nato from the nominal voltage should be operating at plus minus 10% only. Beyond plus minus 10% will be over voltage or under voltage na condition. Over voltage and under voltage, these are voltage responses na beyond, let's take a look at sa Philippine Distribution Code. Na siya ay specific na description. Nakabasa na mo Philippine Distribution Code. 2017 pa niya. Definition of terms ng task. Over voltage. Nabasa na? Nag-study na din mo ano eh?
Grabe, twin bay.
Okay? So when you say over voltage, it's a long duration voltage variation, no? Where RMS value of the voltage is greater than 210%, meaning plus 10%. Beyond more than that, it's called an over voltage. Pero long duration curve. So what's the definition sa long duration curve?
PC.
Long duration voltage variation. When you say long duration, it's called the katong time niya nga component long duration voltage variation is greater than 1 minute. More than 1 minute, nakasa above 110%. Let's say, pinakadali is kini sa outlet, 30 ang iyang voltage nominal. Beyond ka sa 252 or let's say 255 for more than 1 minute, that is considered as over voltage. Kung less than 1 minute, short duration voltage variation na siya. Ang tawag ko na rin niya, kung beyond sa voltage variation, it's a swelling, voltage swelling. Kung under voltage, na long duration, under voltage. Kung short duration, it's called voltage sag. Voltage sag. So, you can, yung mabasa-basa po ninyo ng quad distribution code. Observability, because nato ang distribution line, lesser kahit ang usually ang gina-operatan or gina-monitor sa SCADA system sa ato ang distribution sa utility is more on substations level, substation lang. Pero sa kanang feeder line, very costly na kayo na siya kung even sa mga primary lines na kayo mga monitoring na point to point. So that's why it's a characteristic of the distribution system. Difficult kayo ang voltage control because of the low level of observability. Observability kato mga measurements. Dayon voltage regulators, tara mo auto transformer. Dili si Prime. Di ba kagay mong machines?
Yes, sir.
Ang typical na transformer is a two winding. Gana. Ang auto transformer, unsa man siya? Tanday. Ipatong. Isa na siya ka coil pero same connections ng si primary and secondary. This one is the two winding transformer. Si auto transformer ko the pwede siya inana. Later on na tayo discussion ko na pwede po siya ana. So, ang sa advantage niya, disadvantage niya. Kini siya, pwede din mo na siya i-set ang nominal level, then pwede kang pasakag increment, gagmay lang yung increment ng voltahe para mo-adjust sa ibang secondary side. Unlike sa kining sa two-winding transformer, usually siya gap, let's say 1:10. From 240 mo, voltage rise na to 1,200. Pero kaning sa auto transformer, siguro kung nakay 240 nga input, ang imong increment lang dire is 241, 242, 243, or 24, paubos ko, 239, o 239, 238. So, yun na ang effect sa ato ang transformer. That's why the typical voltage regulator is in auto transformer na construction. Again, ang yung voltage regulation is plus minus 10%. Shunt capacitors are employed also in the distribution system to provide voltage support. Aside from providing voltage support, they also inject reactive power because Q bar of the capacitor will have a positive Q, no? And another notable voltage control device is considered is the distribution generators, which is under the current IEEE 1547 standards.
Sir, tulog ko.
Distributed resources cannot actually regulate the voltage, but when you put up the distributed generators along the distribution line, this could set the voltage fixed. So that's why makonsider siya na mo siyang voltage regulator sa quad. Even sa tuwang analysis na tayo 3 types of bus, di ba? Slack bus, na tayo PV bus. PV bus is katong bus nga may generators na connect. Iset niya ang Q of V o ang P. Voltage fixed siya. Then ang PQ bus, these are the load bus. Ito bus na connected lang is purely load lang. So with the advent of the distribution generators, kini nga itong mga lateral loads sa itong distribution lines could also act as a PV bus, fix ang P o ang voltage level. So that's why they could also act as a voltage regulator. Now for the overhead lines, which is also discussed on the chapter 4 and 5 sa itong reference book, this is the detailed discussion na niya. So, these are the most common method for distributing electricity aside from the cost-effective, no? Cost-effective po din siya sa power distribution, and then these are usually constructed in aluminum, steel, copper, and copper is not generally used because of its high cost. And most of the overhead lines is not insulated. Wala na siya insulator, they are bare conductors. But na ay mga, like for example sa mga protected areas like the Davao, na ay mga distribution lines dito pamutangan siya o insulators to protect the mga bird, kaning kuha nila, native nila na mga gam dito. So overhead lines are not insulated. Agree mo na? Silingan na itong tanaw itong kuwan. Sisipal ko. Insulated ba na siya? Delete? Nasa highway. Ha?
Insulated, sir. Insulated.
Insulated, delete?
Insulated.
Gawin yes, mga gasakot mga bildis.
Sige lang, part of the activity at tayo.
Mga bildis. Lagi gawin na sila.
Because of this exposure, no, most of the distribution or transmission lines are not insulated. Faults or electrical faults will occur when a conductor comes in contact with the ground or simply a tree. No, touch lang ang tree mo.
Kahoy.
Mo kuan siya, create siya of electrical fault. Like vegetations, animals, or people.
Solo kang kahoy. Insulated.
Another discussion here is the underground cables. So you will be shown the basic construction of the underground cable of mass. Mas heavy ang yung insulation sa atuang underground cables because we're laying it in the ground.
May tubig sir mo. Kaya mabasa.
No? Di mabasa, makikit sa ilaga.
Nabaldian.
So, ang conductors lang dala, mga around 30% sa insulator. Ayan pa ang conductor. No? And actually, it's a timely also that you should have a study sa electrical engineering for underground cabling ay nanam to yung issue si City Mayor Clarix Uwing na mga underground cabling sa uptown. Timely lang pero gusto mo malaman sa inyong thesis. Like siguro po, visibility study of the underground cabling.
Yan eh, visibility.
Actually na naman yung mga efforts sa una, underground cabling, underground distribution system. Mga around 2017, nag-comment na rin. Na yung mga proposal na, pero gina-discourage din naman kay sa downtown, ubos pa man ta sa sea level. Pero kung sa uptown, I think that's viable siguro. Especially nga nanay, infrastructure dito. Inside ng Misortel ang nag-retire. So, ilang ipagamit ang ilang infrastructure na sila yung mga underground na facilities na pwede paggamiton na state underground cabling. Inside mo tayo ka na eh. Pwede si Sir Neil, mag-advisor. Nice lang po. Nami actually kung sa USP PLBH, sila Sir Neil man ang in charge ato pag design sa electrical system. One of the option nga lang kita na sa underground cabling. Wala lang to namo na pursue tong underground na distribution. Pag benchmark kami sa Davao. Actually Davao is already implementing underground distribution. Pero downtown area lang nila. So dili gyud totally tibok Davao. Kato ra mga importante nga tao dito Kini, di man po din importante ito na. Uptown na rin, dili kayo sa bahay.
New City na ba sir?
Ha?
New City na ba uptown?
Kasi. Okay? So, but also need to note underground cables of sub-desirable characteristic but also 10 times ang yung cost when it comes to the overhead line compared to the overhead lines. And when the fault occurs, it could be difficult to locate and fix the faults in terms of the underground cabling. No? You have to dig up. Another important component in the distribution system is the breakers, circuit breakers. Kung sa ilang purpose na, one is to isolate faults or isolate disturbances or nasa like asset na biprotektahan. Like for example, si power transformer. So mabantayan ninyo, basic construction sa substation is si power transformer na gina siya incoming o outgoing na circuit breaker. This is to isolate whatever na dili mo sulod sa power transformer ang faults. So the primary function of the breaker is to isolate, to provide electrical isolation if there are some disturbances. And these are designed also to interrupt fault current. So niya pag interact sa fault. So na siya gitawag nga relays. Si relays mo na siya murag microcontroller niya, in which ang iyang mga sensors is CT and PT. So once ma-detect ni CT and PT nga na inrush current, si relays will send the signal sa breaker to trip out or isolate the section of the sa affected na linya. So breakers are only the current interruption device, and other equipments are used to determine when breakers should be opened. There are a lot of medium inside sa circuit breakers to quench the arc. No? Ganun kailangan man i-quench ang arc, di ba kay kung sa linya pa lang nimo, kung nakay high power nag-upload na sa imong kuan, kung imo na siya i-disconnect dito, na siya yung tawag na arcing. So makita mo din sa video na kung high power disconnect. So since intact mo kayo na si circuit breaker, as much as possible kanang arcing yang i-suppress. So pwede siya magamit of air lang na medium, pwede po oil or vacuum or SF6. Again, isang suppress arcing kung that's cutting sa power. Kung na-fault, i-cut off niya. Mabantayan ninyo ng arcing sa, for example, sa manual disconnecting switch. Pag-transfer sa load, nasa ay arcing. Sa pa. Ganang pag sa video good, arcing, no? Kailan ka mag-arcing, no? Breakers are used in all levels of power system. So si breaker lang, ang limitation lang niya is once na siya ma-detect, momentary ba siya or
Susip.
momentary o
Susipta.
Susip.
Susip.
Siya opposite ni momentary?
Susceptible. Susceptible.
Sustain. Sustain. Momentary or sustained na fault, iya siya i-cut off dito. No?
Alay.
So, ang yang magulang-magulang ni breaker dayon, mga na si recloser. Okay, pwede niya i-suppress ang fault with a short period of time and then pwede niya ibalik automatic ang line. But before we go to the reclosers, let's have the switches. Switches na, kini siya, wala siya ay detection sa inrush currents or inrush faults. So its primary function is to provide electrical isolation. It's not a protective device, unlike the circuit breakers. But switches are used to in the substation to transfer of load or kung may maintenance, na siya ay configuration sa substation. And other, no? Dagan kani siya function si switch, or we normally called it as the disconnecting switch, DS. So protective devices, we have cut-off fuse, no? And then isa ning isa. Kini siya, isa din. Fuse man no? Asa yung fuse na? Kini. Kini fuse. Kini unsa man Bangkok siguro. The closer. Nanangin sa sa closer.
Ay, dito, recloser lang.
So,
Kung kilig
again, later
Kilig sa building dito.
recloser
Switches
is
na to ba?
essential, for example, sa kining mga heavy crowded areas na dito. Para ma-capture lang niya ang or ma-prevent niya ang mga momentary na faults. Kung difference sa momentary and sustain. Sustain, I think, let's say 10 seconds beyond considered as sustained na faults. Kung momentary na faults, like siguro natagakan ng kahoy or 4 seconds and then na-disconnect na yun. So that should be ang imong power interruption should be 5 seconds lang po dunta. Pero kung wala kay recloser, mahitabo na ma-disconnect na siya sa imong breaker. So si recloser, it's much possible na itong i-detect na momentary ba ni? So kung ibalik niya connect, kung napagyapon ng fault, meaning sustain siya. So protective devices, these are able to detect faults, no? So what are these? Unsay cause sa faults? Could have a vegetation. No? Normally, common nga cause sa fault, especially for a tropical country, vegetation, no? And especially kung
Sa bukid sa.
pinano maningil sa kuha, no? Tamnan ginana yung kahoy ng ilalong sa transmission line. Vegetation, storms, kining kuha na ni siya, force majeure or kining may bagyo, no? Animals like snakes,
Monkey.
unggoy, pwede po
Unggoy
unggoy, may go unggoy.
Gagas, guys.
People na mabanggaan sa tao ang poste. Or kung sa kalamit sa poste,
Langgam, sir.
pilang niya.
Sir, kato langgam dili.
These are some of the common cause sa electrical faults.
Tara
Sir,
po.
langgam, sir.
Langgam.
No, di sila ko
Pwede magdanggap. So that is in the distribution level Pero kung sa household na level, dito na, malakpan na sa imong either sa imong balay na circuit breaker or sa imong fuse. Like for example, yung isuksok ang tinidor, i-expect ka na mag-brown out sa sipal, tanaw, brown out sa sipal ko na. Actually, mga dito ang katong mga first, mo, downstream yung mga
Breakers.
protection devices. We have the circuit breakers in our own home. Na kung naida kong naka-inrush ka rin, demand, trip siya. Second in line of protection is naka-cut out fuse sa imong transformer. Para di ka makadamay sa imong silingan, higay ka katulog. Then, there are a lot of set of redundant na mga protections para dili gid siya mo cascade ang imong faults. And this is a basic one ini challenge sa electrical distribution system ang pag-detect or pag-avoid sa fault, pag-detect and pag-restore due to the faults. And service transformer, these are the we call it sometimes as the distribution transformer. No? Kaya siya special type na transformer. May pole mount, ground mount na transformer. Service transformer are used to lower the voltage from distribution level to the usable customer levels. Could be overhead or pad mounted. Could be a single phase or three phase, and in the US it's they have the 120 and 240 available na voltage. And a single three-phase or distribution transformer can serve a multiple customers. Then triplex cable, or we call it as the service drop or service entrance, or service drop from the pole connection to the customer. So to the end consumers. Utilities generally have guidelines on how long is this cable. Sa Sipalco, limit of 50 meters from the pole, from the end or the last pole na connection. Beyond that, mag-construct ka kaging mong kabaling ng pole. Limit sa distribution code 50 meters. Sa end-use loads has a lot of kanina yung mga gamit mo. Could be in terms of the residential load, could be classified as the HVAC, lighting, entertainment, household. For commercial loads, HVAC, lighting, entertainment, industrial loads, HVAC, lighting, heavy machineries, and for agricultural loads, we have a large pump motors. For like we have a VFD. And distributed generators are also considered as component inside the distribution system. Okay. Nowadays, we could have small wind turbines in our home or solar PV.
Ano? Wala pong remote power plant.
Wait lang.
Para din. Win.
Win dyan.
Post tayo, post.